Alrighty, if we can get going, it's 3:30. I'd like to welcome you all to creating connected apps that work on today's networks. My name is Peter Smith, and I'm a program manager at Microsoft. And I've been a program manager at Microsoft for about 3 years, but before that, I was a developer, and I was actually a developer for over 20 years, and working on all sorts of apps, and every single one had networking involved in it, and I had to do something with the networking in every case. So I was delighted to join Microsoft about 3 years ago, and I work now in the Network Developer Experience Platform team. And what we do is we try to reimagine what the Windows API looks like and what the networking API looks like to make it much easier to add networking to your app. The goal of today's talk is for me to talk about some of the work we've done to help you make a great connected app. Something that's simple for you to get started with, but also simple for you to finish, something that your users will appreciate, something that your users will value. Now, some of the prototype work, some of the startup work, we'll get into how you use the APIs. I'll be showing off code samples, going over some of the tips and techniques that I've learned from creating some of the demo apps that you've seen here, and some of the demos that you'll see right here. And with that, let's just jump right into my demo app. Now, the demo app, and here's the Visual Studio. I'll show its actual real running code. So what I did, I was a networking guy. I set up a little server, and the server is that away over in the whole Pod Expo area. You can actually see it sitting there in the rack. And I made a little server program in C#, because I'm a System.NET PM. Wrote a little app in System.NET, and what it does is it listens for strings, and those strings are file names. And it opens up that associated file, and then writes back 4 bytes of the file length in network byte order, and then all the data for the file. The string, of course, is UTF-8. The client app that you, whoa, I'm sorry. Here I am rabbiting on about this, and you can't see my laptop. There you go. This is my client app. So what you see here is my client app is asking for a series of images. There's actually 60 of them. And it displays them one after the other, and it's doing it about 20 times a second, and so that's how you get the whole, flipbook effect. Now, I said that our APIs are here both for helping you start programming and also to make a finished product. Let me show you what I mean by the finished product. This is the Ethernet cable that's connected me to my server. If I pull it out, what I expect the app to do is to still be an app. When people are using your app, if you're writing a photo app, you want people involved in your photo app. When you write an editing app, you want people involved in your editing app. The last thing you want them to see is a giant dialog box. And so this app handles that. This app carefully and nicely handles the fact that I pulled the Ethernet cord out. It actually has a little orange dot now saying I don't have network connectivity. When I plug back in, it'll get started working again. Huh? And the networks have been a little bit funky. So you can see it's actually retrying and retrying here, which is kind of cool. There's another bit of thing that makes this a more finished app. All those computers that you got yesterday, they all have, from a mobile broadband operator, network connectivity. You can have network connectivity anywhere with those computers you got. But you know what? It would be cool if when you're running this app, it didn't suck up your entire allotment of bandwidth. And it would be cool if when you were roaming, it didn't suck up like a lot of money from you. Let me show you what this does. Let's suppose, and here I'm going to go to my little QA part of it, quality assurance. Suppose I was roaming. Well, when I'm roaming, I certainly don't want it to do anything. And so indeed, it now says, based on network information, network usage is not allowed because it shouldn't do anything while I'm roaming. But just in case I actually do need networking, I can turn it back on again. Allow regardless and start it again. And notice, now it's actually telling me that it's expensive. It's also downsampled all the images. Now, it does that, of course, the server doesn't know how to do that. I mean, the server has the images. It's the client that knows if it's expensive or not, and the client asks for lower resolution images. And once again, I can actually tell it to please use the, oh, yay, higher resolution, and before I use up all my company's fake money, let me not do that. So we want to get you started quickly. We want to be able to add finishing quickly. Let's talk a moment about the code behind this. We have a little protocol between this client app and the server. And I got to send a string, and I got to read an int, and I got to get data back. How many lines of code do you think that is? Well, it turns out that it is that many lines of code to do the basic image loop. And this is my little prototype thing. So it doesn't include like the retry, and it doesn't include this cost because I'm just getting started here. Well, shoot, that's not very many. And more importantly, sorry. And more importantly, we reimagined what the network API should be. And in this case, I'm doing sockets. And let me dive just a little bit into what we've done to reimagine the network APIs. I said that the net length information was in network bytes order. And here I am reading my length information. I read an int32. I don't have to do some extra function call to tell it, oh, by the way, I'm in network byte order, and please take a little bit of stuff out of my buffer somewhere. It's all in there, as it were. Let me, at this point, jump into, there we go, that's fine. So like I said, the goal of this API is simple for you while delighting your users. Easy for you to add the networking support that you need. Why? Well, we all want to make rich connected apps without doing a lot of work, without doing a lot of coding. That's what this app platform is for. Let me now talk about the APIs that we have available for you. Let me go through a list of what we have and when you'd use it and the scenarios under which you would use it. You may have seen this slide before. This is all of the APIs available in the runtime. This is the overview, as it were. And you are here. You are in the communications and data area, which is, as you can see, a lot. Let's dive a little further into what that means. Well, we have a bunch of HTTP APIs. And we have, in fact, a couple different sets of them. The first set, and it's over on the left-hand side, RSS, Atom, AtomPub, we have syndication APIs. Because we know when you do HTTP that one of the things that's very common to want to do is to do RSS and Atom, the syndication stuff, to read in updated information, constantly updated information. It's in a standard format, and we know about that format, which means we can do that easily. We can present that data to you easily. You can consume it very easily. It's split out here between both RSS and Atom. Our API actually does not particularly distinguish between the two, which means you don't have to know ahead of time what your format is. We will handle that for you. You can also see there's WCF in there. And further on the right, there's the IXHR, HTTP client, XHR, HTTP web request. These are our HTTP APIs, the ones that do this, the gets, the posts, the deletes. And let me stop for a moment, because in a lot of the presentations you've seen so far, we talk about how the runtime, how we created the runtime by adding into Windows, and then it gets projected into the different languages that we support, the JavaScripts, the C Sharps, the Visual Basics, the C++s. And we did that for an enormous number of APIs. And one of the ones that we didn't do that for, one of the ones where we chose not to do that, was for the HTTP APIs. And the reason is that all of our languages already had a perfectly reasonable API that people already knew. Our JavaScript developers were already very familiar with how to use like the XML HTTP requests. There's no extra value we could make by creating a different API. There's no extra improved speed for creating your programs, no programmer productivity improvements we could make. There's no finishing improvements we could make, so we decided not to. Now you'll notice along in this list is HTTP client, which is a .NET API. I said we had all these great APIs that people were familiar with. This is actually one you may not be familiar with. That's because the HTTP client is brand new in .NET 4.5. there'll be a presentation that includes it, which I believe is tomorrow. Now, jumping up in abstraction levels, we have our web services APIs. What do these do? Well, the HTTP APIs are for when you're going to some web service and you need gets and posts. But you know, a bunch of web services we believe will be so common that we want you to have a straightforward API direct to that web service. And that's things like SkyDrive and Live and Azure and Xbox Live. Every single one of these has a talk at one point or another during build. Diving lower level, we have data APIs. And just like our HTTP APIs were both higher level and lower level, we have higher level and lower level data APIs. So what are all these? Well, a common thing to want to do in networking is to consume or produce JSON or XML formats. And no surprise, we have APIs for JSON and XML. Another common thing to want to do, though, with networking is you get a stream of data and you just want to plug it into some other thing that also takes streams. And it turns out a lot of stuff in the runtime handles streams directly. The files, they handle streams. Things like the microphone, the speaker, all these handle streams. The encryption, decryption, compression, decompression, these are all streams, which means you can take a stream from one, and the goal is to be able to plug it into another without having to parse and figure out what the underlying data is, because everything is compatible because they're streams. And then lastly, at the lowest level is data reader, data writer. You saw up on the screen a little bit of the code for that. Data reader, data writer gives you access to all of the bytes coming in or going out of your network. You have full access to every single byte. You have access to higher level constructs like, hey, I want to send an int, I want to send a double, I want to send a string in. We have information APIs. Why? Because people need to know information about their networking as a whole. Not just a particular connection necessarily, but what is my internet like? What adapter am I using? What is the cost on that adapter? You saw that in the demo program that it had cost associated with it. Well, you can get that cost information out very easily. Background APIs. All of you have used your slates by now, I hope, and all of you have noticed that the foreground application always seems to be very what we call fluid. That is, it gets all the CPU time. The corollary to this is that if you're not in the foreground, you're not getting into the CPU time. And for a lot of apps, that's totally good, because they're not doing anything that the user needs to see right then. They're not doing anything that would progress the user in their tasks. And so it's okay for us to then not give them any CPU. But some network things, on the other hand, are not that. And let me give an example. If you're writing an app, or you've got an app, the user has an app, and it needs to download a bunch of data. That happens, right? You need to download the latest movie. You need to download a big data file. You need to download some large chunk of content. And you tell the user, oh, by the way, it's going to take 10 minutes. And what do? They start playing a game. As soon as they start playing a game, of course, your app no longer is getting CPU and therefore is not progressing. The user finishes their game 20 minutes later, goes back to the app, and it hasn't done anything. Result, unhappy user. Well, that's what the background APIs are there to solve. We can upload and download in the background. That is to say, even when your app is suspended. In the case of the RTC APIs, we can do the RTC. The RTC APIs are therefore like a VoIP-style program or a communicator-type program. That is, if your program is supposed to sort of be sitting there running and then eventually someone will contact you and it needs to then do something, well, you can tell the RTC APIs, hey, this socket is important. This socket I need to keep listening on. You need to wake me up when something happens on this socket. There's a whole talk on the RTC, so if that's your kind of app, be sure to go to that, because there's actually some restrictions on what you can do as an RTC app and how many of them there can be on a system. And lastly, push notification, which is, in my opinion, one of the more exciting of the APIs. All of you, by now, you've got your tablets, which, by the way, I don't have. You all have your tablets. You can play with the Metro-style apps. You'll notice that a bunch of them actually update their tiles. And you might not have thought, like, wait, how is this app updating its tile? Because it's surely not running in the foreground. And the answer is because you can have a web service that tells Microsoft basically to update the tile for you, which again means that your app looks as if it is working in the background because in essence a proxy for it on your cloud site is doing the information for you. Lastly, of course, you can't talk about networking without getting some of the foundational APIs like socket APIs. We reimagined how socket APIs work, and I think I'm personally very excited about them. TCP, UDP, the classic sockets. In addition, we handle SSL very cleanly. In the past, to handle SSL has been an enormous burden, an enormous amount of work to get it to work for you. Now, with our sockets, SSL is just a question of telling it to be an SSL socket, and it will automatically handle the negotiations for you. We handle WebSockets in the RTC. You may have heard of WebSockets as part of HTML5 as a browser kind of thing. Well, we imagine it bigger than that, because a WebSocket is really a socket that can get through proxies. And it has attributes similar to any other kind of socket, like a TCP or UDP socket. Why in the world wouldn't we just simply present a socket to you that works just like a TCP socket, only it gets through proxies? So there's a complete WebSocket API as well. And lastly, proximity sockets. This is for the tap and go, tap and connect that you can do with your slates. All of your slates have near-field communication in them. You can write a multiplayer app that you can do a tap and connect, and it will work. You will connect two people automatically. And let me stop also and say one other interesting thing about our APIs, because there is one other aspect to networking that isn't mentioned on this slide. And the other aspect of networking is that some of the best networking of all is when you don't have to do any networking yourself, when someone else has done all of the work for you. And you've seen that in the keynote when they talked about, for example, the sharing contract. I've talked to a bunch of you about networking, and some people say, you know what? I'd love to take my game and I'd love to share information from it. I'd like the user to be able to share information from it onto popular social networking sites. Except none of you has actually said social networking sites. You all said explicit name brands for particular ones. And I've personally tried to hook up applications to Facebook in the past, just because I'm interested in that kind of network programming. And it's a lot of work. I mean, it's a lot of work to connect. You've got to figure out their API, and you've got to figure out the authentication that you need to do to get from us or from your app out to those websites. And not only is it a lot of work, but it's a lot of work for every single one. So you connect to one site, and that doesn't mean you can connect easily to another site. And that's what the sharing API is so great about. All you have to do is fill out some data. What is it you want to share? The user then gets to pick. I want to share with this site. I want to share with that site. And a different app entirely that you don't have to write will actually do the connection for you. Similarly, we have the synchronization APIs and similar ones that will handle networking for you in your apps. Oh, settings APIs is the other one, not just sync. It's settings APIs as well, which means you can, in your app, here's a scenario. You've got like a magazine app, and someone's on say, page 76. They go to a different computer and log in as the same person. There's no reason why those settings shouldn't transfer over right away. You saw that actually in the keynote when someone took a picture of themselves as Mort and used that as their tile. And then it automatically transferred over as a setting over to other computers. They didn't have to write extra code to do that because their settings API already handles that for you. And for those of you who want to actually learn more about all these things, I've put some of the talk numbers for them. There's too many Azure talks to even list them. The HTTPs is all talk 581. I know the PM who does that one. It's going to be a great talk. The data APIs and the sockets is in talk 580. Web services, well, you can all read it. All right, let's jump now from talking about the APIs in general and talk about them in specific. I said I'd share some actual code samples with you. In this case, this code sample was actually, I believe, part of the newsreader that is on your slates, or it was developed for that newsreader. If you've tried to do various forms of RSS and syndication and Atom in the past, It's not particularly hard, but there's a lot to actually got to figure out, and the formats, and is this site this type or that site that type. This is the code necessary, and it fits all onto one slide. This is the code necessary to do syndication. That's RSS and Atom. In this case, what we're doing is we're getting information about each feed and then doing something with it. That actually, where it says this title and image and stuff, sorry. So you make your syndication client. You do it with Windows Web syndication client. You make your object. You can then call retrieve feeds async. That will actually retrieve the feed for you. And it will retrieve information about the feed in particular. You can then use that information and update your user interface. The title, the image, the summary, the updated time. We have information APIs. And what I'm going to do is I obviously can't talk about every single API, but I can talk about a bunch of them. So the information APIs. The information APIs in networking tell you about cost, they tell you about the network and what's happening with the network. And one of the interesting things you can do with the information APIs is get network change notifications. When I pulled this Ethernet cord out of my laptop, I got notified that the network had changed and that maybe I ought to do something about it. And when the cord gets put back in, I get another change, another notification, and I get told, hey, something happened with your network. Now, as a person actually in the core networking, I happen to know about the kinds of events that you actually gets generated just plugging in an Ethernet cord. It sounds so simple. I plug in an Ethernet cord. That should just be one thing, right? Haha. We plumb, let's see, we find out there's Ethernet. We find out there's IPv4. We find out there's IPv6. We plumb different IP addresses at different times. We detect the network. We do DHCP and automatically get the IP address for you. And then we do other Teredo stuff, and it's a lot of events that bubble up. And what we've done is we looked at all those events and said, you know what? What people really care about is the last event. Right? Not the first event, not the second event. You care about the last event, because at that point, the network is stable. And that's what we've done with the network status change. We make sure, I'm an electrical engineer, so I call it debouncing. We debounce the information for you, so you just get told, hey, something happened. Now is perhaps a good time to reconnect. To do it, Windows Network and Connectivity, network information, remember that set of words. That's an important class inside of networking. It has tons of information about your network. And from that network information, you can get to other objects that will tell you even more. You set the event listener, the network status change, and tell it what event to call, or sorry, what function to call. And it'll call that function for you every time the network changes. We have background transfer. Remember I said that applications ought to try to that applications that download a lot of data can be frustrating to users. It can be frustrating to users because they see the background, the data transfer will take a long time. And when it takes a long time, they start playing another game, and then the transfer doesn't continue on. It doesn't progress. And this is our solution. It's called background transfer. And if you've just been looking at this code up here, I mean, it's a download from a URL to a file, right? So you have a URI. You pick the file you want to download to. In this case, I'm downloading from data.iso to download.iso. Once it's made a file, you make your downloader a Windows networking background transfer, background downloader. Once you make that object, you say start download from the URL to the file. And you think, well, cool. So it downloads, okay. It downloads in the background, okay. Even if your app is suspended, cool. Your app can be terminated. It'll keep downloading even if your app is terminated. You remember my app handles cost. This will actually, because I didn't set any of the options on it, this will actually not download on a roaming network because we think that would probably be too expensive. It won't download, I believe, on a variable network either because we think that'll be too expensive by default. You can set it to download on those kind of networks if you want to. But wait, it does one other thing. Remember the whole pulling out of the Ethernet cable? It handles that too because it'll restart automatically on the right network. Well, that's a lot of stuff in one API, and that's when we say we reimagine the network API this is the kind of thing we mean. You get started your network program quickly by using the background transfer, and you can finish by adding the polish that your customers expect also very easily, because in this case, we've practically done it for you. I should point out, though, there's one downside to this. The downside to using background transfer is that when you're suspended, all of your threads are frozen. The way we can have one thread that's not frozen is because it's actually not in your process. And that implies that we have to make another process, which means if you're downloading just 10 bytes of data, it's a lot of overhead for 10 bytes of data. If you're downloading a couple megabytes, it's probably worth it. All right, let's jump into WebSockets. WebSockets, it's an API that looks like sockets. If you remember what the code before looked like, the WebSockets code looks very similar. You can make a socket with the Windows networking socket, Stream WebSocket. Before, when I made just a regular socket, it was the Stream socket. This is Stream WebSocket. You connect to a URL because WebSockets connect to a URL. Once the connection happens, I can make my data writer. The data writer lets me write strings. The store async actually does the send. And one of the little tips, by the way, if you don't do your store async, the send will never happen. And that's true for everything about streams, by the way. Even if you're doing things like, I've got some data and I'm writing into a memory stream, you still got to do the store async. And in this case, when it was done, I decided to just close the socket. Let's talk a little bit about data writer. Data writer is our way of controlling all the bytes on the wire. So you can have absolute control about what gets sent. And I mean, it's straightforward to use. I mean, you make your data writer, Windows storage stream data writer. You give it the name of a stream that you want to control. Sockets have input streams and output streams. You say what the variable you want to handle is. In this case, what I'm doing is this protocol in particular. I'm going to send a string, but I want to send the length of the string. And I'm sending it in UTF-8. Well, hey, we can measure the length of that string. So when we write it out, we actually know how long it is for when we read it in. The other things that data writer has on it is to read all kinds of integers, int 16, 32, signed, unsigned, 64 bits, floats, doubles, all the whole gamut of the data types that you want to do. So that should give you a little bit of introduction into some of the APIs we have available to us. And hopefully you've seen that they're straightforward to use, that they're short to use, which is important, that the code was all fitting onto one slide. And I've mentioned that it's easy to get your app from started to finished, started to completed. Let's talk about one aspect of completion, which is how to handle network changes. People want to take your app everywhere. And one of the things that you want to do is to have it work smoothly across networks. Now, I was just pulling the Ethernet cable out. You guys with your slates that you picked up, those slates, with the networking it has, I bet you've already gone to different places that had networking and expected the network to work. And I bet you've already run apps and moved from one spot to another without even thinking about it. And naturally, you want all the apps on the tablet and the apps that you create for your users to handle those network transitions smoothly. Now, unfortunately, it's not something that we in the network team can actually solve entirely for you. But there is a couple things you can do with your app that are very straightforward that will make that transition happen smoothly. Now, the classic thing that people do with networking is you try to connect, regardless of the API you use, whether it's a socket, whether it's HTTP, whether it's the syndication APIs. You try to connect, you check, hey, did it work? If it worked, use the connection. One tip, by the way, for HTTP people, for people who do HTTP-style communications. One of the things you have to check for, and the reason it says worked ? Is working doesn't just mean that you sent a request out and you got a response that was 200 OK. It turns out that in a bunch of places, like, for example, hotels, coffee shops, airports, in a lot of places, just because you got a response back that was 200 OK didn't mean it actually came from your server. This is called the captive portal problem. Captive portal. And in this, you send your request off, and the portal you're talking to, the little router that you're talking to right at the coffee shop, at the airport, at the hotel, it is sending the 200 OK back, and instead of sending data from your server, which hasn't even been hit, instead it's sending like an HTML form, and would like you to enter a coupon code or a receipt or your room number. And obviously, since you're not writing web browsers, probably the user's never going to see that. It's important that you look at the data as it comes back and make sure it's actually from your server and has the format you're looking for. Anyway, that's a small digression. So this is the classic network, right? You try to connect it, it worked, use the connection. The new thing is if it didn't work, wait for that change notification. Waiting for the change notification, and then when you get a change notification, do something about it, which would be to obviously try to reconnect. You notice the words on here also say with a timer plus a backup. Not every network condition is one that the client will ever know about. For example, your server was rebooting. We don't know that your server rebooted. There's no way for the client to notify anyone and send an event out. And so you just have to use a timer because there's no other way to tell that the server finished rebooting. You got to do it with a backup, by the way. All those slates you guys have that has the nice 3G or 4G networking in it, well, that all has a data cap, and you don't want it all used up. And part of not using it up is not whacking away at the network way often for hours at a time. And the last part of keeping the network working smoothly, and this is the last of 5 boxes, is if you're still working, well, you keep working. If you stop working, wait for the change notification and try reconnecting. Although it helps the very first time you get a failure to try right away, because an astonishing number of cases, in fact, if you retry, it'll actually all work again. And let's see, our demo here. So we've seen in here how we can do the whole connect and reconnect. When I wrote the code to do the connection reconnection, I wrote it all as a separate module. And I thought you might be interested in seeing not necessarily what that module is, but how that module interfaces with my code. So this is my business logic. This is my business logic. That is just a demo slide. This is my demo logic. This is my my business logic. So in my business logic, it turns out that the interface that you need between your business logic that needs to decide about connecting and reconnecting and the whole set of stuff that decides when to reconnect is actually very, very simple. And you can do it with just 2 functions. You can do it with just, hey, start network and network error. Whatever module you make that decides when to reconnect, all it has to do is say, now's a good time to start. And the network error, your module calls whenever you see a network error. And the actual code, by the way, to handle the whole sort of state machine, 100, 200 lines of code at most. But there's no way to go through all that. So we've seen about how to get started network programming. We've seen how to do some of the fit and finish necessary to complete your program. Let's talk about bill shock and eliminating the bill shock surprise factor. Users are taking their apps everywhere. It's just part of how their lifestyle is. And all of you have laptops that have like Wi-Fi on them. Well, you can take it to a lot of places and run. You can take it home, business, school, to the coffee shop. With those devices you have, you can now take it to even more places. You can be doing your work on a bus. You can do work at a park. You can do work at the beach. There's a downside to this, though. There's a downside to using the connections from mobile broadband operators. And the downside is that it's possible that the $20 a month payment that you're expecting to make or the $30 a month payment you're expecting to make actually balloons to a little bit more in a way that you find surprising and unfortunate, to put it mildly. And here are actual headlines that we've seen over the last couple of years about people who have run into trouble while using the cell phone data plans while roaming. And in some cases, while they didn't even realize they were roaming. And what we've done in Windows 8 is to try to make it possible to enable the mobile broadband users to use their connection with a lot more confidence. And the way we do that is we expose a lot more of the network cost information. And the greater visibility means fewer surprises. Now, part of what we do is just simply exposing it as code to the developer. So as a developer, you can find out, even on your devices right here, exactly how much it, well, not exactly. You can tell roughly how expensive your connections are. The code itself, oh, I didn't put the little boxy things. The code is straightforward. In this case, I'm grabbing my cost information with the Windows networking connectivity network information. Remember I said that was a powerful object? It is, because from the network information object, you can get the internet connection profile. What's that? The connection profile in general tells you about your network, essentially, that you're on. The internet connection profile tells you about the network that you're going to be using for internet connectivity. And those of you who've been doing a lot of networking, and especially data center networking, because these people do it all the time, know that in theory you can set multiple adapters on your device and have different ones pointing to different spots. But we find that's not how the average client device is set up. The average client device is set up so that one adapter will be used for networking. It's connected to one particular network, and we can find out information about it. Which means that if you're doing a web service type application, a service that's pulling in weather data, that's pulling in map data, that's pulling in social network data, over from a public website, then you just get the internet connection profile and take a look at the connection costs. And to get that, you call get connection cost. What does that cost consist of? Well, firstly, it has a network cost type. And this is a cost type that was given to us by your internet service provider, by the mobile broadband operator that is giving you your internet. And there's 4 different types. One is unrestricted. The unrestricted type means that there's no particular cost associations with using that connection. Unknown is a transient state. You're unknown only as long as we have not identified your network. By the time we've identified your network, we will know what the correct cost information is. There's a fixed type plan that we find is very popular. That's where you pay a certain amount per month, and you get a certain amount of bandwidth. I think that's how all of your devices are set up right now, that you get a certain number of gigabytes per month. And lastly, there's a variable where every single megabyte or every single kilobyte costs extra money. Something I should point out, by the way, is that in case the ISP has not set your machine up to give you this information, we have reasonably intelligent defaults about what the connection costs probably are, which means that if you just plug in Ethernet, well, probably that's unrestricted. It doesn't have to be, but that's probably what it is. And same with Wi-Fi. Right? With a Wi-Fi connection, pretty much all of them are unrestricted. So once we get the network cost type, we also find out 3 more bits of information. We find out if you're approaching your data limit. We also can find out if you're over your data limit. And lastly, we can find out if you're roaming or not. And roaming is important because roaming is much more expensive than any other kind of networking. And I actually went to a really interesting talk at Microsoft. And they brought up why roaming is expensive. And I hadn't known this, and I figured a lot of you might not know it either. The reason roaming is expensive is because of the way the different cell phone companies have set up their peering arrangements. Let me explain. If you have internet service through provider A, but you don't have coverage right where you are with provider A, you're not near one of their towers, and instead you're going through provider B, well, they have an agreement to to handle the billing for each other. And the way they do that is that provider B will actually send every single one of your packets over to provider A. Which means that if you're, for example, on another continent, every single one of your packets is traveling over like in an undersea cable. It's like, well, no wonder that's expensive. I mean, you can't just send stuff over a cable for free. Anyway, so roaming is more expensive, so we tell you about that. Approaching data limit, over data limit. Other important thing to know about these is these are from the ISP. That's information generated by the ISP and given into Windows, and it depends on their background, their own accounting systems. Some accounting systems are faster, and some accounting systems are slower, which means you don't get like up to the second data. You get up to the hour data, up to the day data. Depends on the carrier giving that information to us. Roaming, however, we usually know within seconds, apparently, is what I'm told. All right, so this is raw data. But we need to make a decision about what to do with this raw data. In my sample app, I made some choices, and let me share with you the choices that I made. When I customized my app to the network type, I split it into 3 networking states, and one was normal. I said if the network state is unrestricted or unknown, then the behavior should be that there's no restrictions on the transfer of data. I could just make up a socket, and I could send the high-resolution images. And I also have a state that's conservative, and the network state is, well, that's when it's fixed or variable, when I think that there might be more cost associated with it, in which case I still use the network. Right? People get their mobile broadband cards because they want to use the network. They want to be connected wherever they are. And so don't like to not do it. Of course you should allow networking. But be mindful that it's costing them money. And in this case, you should, for example, transfer less data. What does less mean? Well, in my app, I transferred lower resolution images. They went from an average of about 4,000 bytes to an average of about 500 bytes. That's a pretty good savings. But at the same time, I provided a user override option because, again, people get these plans because they really want to use them. If they want to use their cap, or if they want to pay to get high-resolution images, then they should be able to do that. And lastly, there's the opt-in state. This is for example, when you are roaming or over your data limit. And why? Because we know from experience that in general, these are very expensive states to be in. And so we have to let people opt in to these behaviors. And so I don't transfer data. But again, I allowed the user to override my decision because maybe you're roaming and you really need to use that app. It's important to use the app. And so cost awareness, let me just show you the code I wrote for cost awareness. And in particular, the code I wrote to turn the general information, the raw information, into an actual, thank you, into something actually actionable. Poof. So, step 1, I actually get the connection cost. This is the raw cost. Although technically I take it and copy it into my own object with a little shallow copy. I do that for 2 reasons. One, because I want to modify it. And one, because actually this get connection cost, I could click some buttons and it would change the cost for me. I wanted to be able to click some buttons and change the cost. So get connection cost handles all the button clicks, and I've already told it I want to be roaming. I then figure out if I want to be fixed or variable, and so here I'd actually calculate, am I fixed? Am I variable? Why are these separate lines? Because these are long lines. I like short lines in my code. I then figure out the state that I want to be in. Do I want to be opt-in? Do I want to be conservative? Do I want to be normal? I first figure out, should I opt in? Am I roaming or am I over my data limit? If I am, I want to opt in. Do I want to be conservative? Well, that's either fixed or variable, and not opt in. And lastly, normal is everything else, and logically speaking, that would be the other 2 cases. And lastly, I also want to set a couple other things. One, I like being able to say if I should put the little dollar signs, so I said if I was high cost or not. And then lastly, I wanted to say if I should allow the network, because this is a choice that my program has to make. And so in my object, I want to make that choice explicit, and I only want to make it in one place rather than duplicate the code all over the place. All right, so we've seen now about the APIs that you have that can get you started and get you going and get you finished. We've seen one aspect of getting your application finished. Let's talk about another one. How many of you have written an installer for your app in the past? And there's a couple. How many of you wrote an installer because you were the most junior person on your team? And that's why I wrote one. Everywhere I worked, the most junior person has to do the installer because no one else wants to do it. If you do networking, you know that when you install your app, you've got to handle the firewalls. Because if you don't, then when the app runs, the firewall pops up and says, hey, do you want to block this app? I'm going to put up a scary dialogue, and the user has to click OK. So you've got to plumb your firewall rules in your installer. And those of you who have plumbed firewalls and rules in your installer, which luckily I've never had to do, but I've read the documentation on it, I'm glad I've never had to do that. Well, the good news is Metro-style apps install with the firewall rules set up automatically. We can do that because we have what we call capabilities inside of the application. The capabilities is simply a list of things that your app is allowed to do. It is inside what we call the app manifest. Every app, JavaScript, C#, C++, Visual Basic, all of these that are Metro-style apps have a manifest, and every manifest has a list of capability. It includes a lot of stuff. You can say whether you're allowed to access pictures directory. You can say whether you're allowed to access, the webcam or not, or the microphone or not, because we want a lot of confidence for people that when they download an app that it won't do something that they don't expect. And amongst those capabilities are 4 network capabilities. The most common one that you'll probably be using is Internet Client. That's because when I've talked to a lot of you about the kind of networking you do, a lot of people want to talk HTTP up to a web service, up to a public web service. Well, that's Internet Client. I want to go to the internet, and I am the one who is creating the connection. It's not saying what direction the data flows in, because the data goes both ways. Right? I instantiate a connection to do an upload, or I instantiate a connection to do a download. In either case, I am starting the connection, and then stuff goes both ways. What kind of apps use this? Are you doing social networking? Are you a syndication? Are you using a web service, maps, weather, stocks, all that stuff? The next one is Internet Client and Server. Exact same kind of thing, only now your app, in addition to opening a socket and sending it out onto the world, in addition to that, your app is creating a listening socket, and someone is calling into you. And as soon as someone calls into you, that's a different level of capability that you need, and that's what Internet Client and Server is for. Our guess for why people would do this is if you're a peer-to-peer application would be the number one reason why you'd want to have a capability like this. For example, an instant messenger, for example, a VoIP-style application. There's home and work networking. And the interesting thing about this is it carries with it the implication that we can tell the difference between your home and work network and the internet. And we've got a bunch of code to do exactly that. And one of the hard things about it is that if you're doing HTTP, for example, the server you're hitting, technically that the socket is going to, may well just, in fact, be your proxy, which is considered internet, not local. That's one of those extra rules we have to plumb in. What kind of stuff does home and work networking do? Well, apps for sharing within the home is a very client-oriented one. A lot of you that I've talked to are also doing business applications, line of business applications, things used inside the enterprise, and that, of course, would also set the home work networking flag. And the last networking thing is for the near-field proximity, and it enables you to do the tap and connect that a lot of apps, I think, will enjoy doing. The number one for this is it talks about connecting together with PCs. This might be a sharing, a collaboration, or a competitive thing like a game. There's another reason for capabilities, though. It's kind of nice that we can use the capabilities to plumb the firewall rules automatically. That's actually not why they were put in. We actually have capabilities because people want to try new apps, but they're not quite confident about what the app will do. They're not quite confident that their app will actually do what it says it does and it will not be some sort of malware. By having every app list in their manifest the capabilities it's using or not using, we can increase the confidence that people have in apps. And this is important because the more confident people are that apps from the App Store are trusted, the more they'll download. Capabilities make deployment easier. They increase user confidence. Let me actually show you the demo on that. In this case, there we go. So here's my program. This is my app manifest. Has a bunch of tabs in it for application UI and declarations and the URIs and packaging. This is the capabilities one. And right here is the home and work networking that I had to click, along with Internet Client, because our servers do that. I had to pick home and work networking because this is a private network. I also had to click Internet Client because at one point when I was developing this app, I was doing it actually over the internet. So I had to pick the capabilities that I wanted to give. Notice that I'm not selecting any of the other capabilities because my app does not need those, and I don't want to give a false impression about what my app does. All right, so let's recap what we've seen. We've seen that there's a whole bunch of APIs inside of the runtime that are designed together to work together, that will get you started, that are at multiple levels of abstraction. The multiple levels of abstraction means that when what you want to do matches a higher level API, you can just use the higher level API quickly and straightforwardly. But if you need to do something else, something more sophisticated, something more custom, we also have access at lower layers all the way down from web services, down from HTML and HTTP, all the way down to TCP and UDP sockets with complete control over what gets sent. Now, as an overview, of course, there's a whole lot of networking sessions here at Build. I tried to list a bunch that you might be interested in going to see. I've seen a lot of the early presentations of these, and I'm actually very pleased with the way they all run, and I think they'll all be very interesting for you. I see we have about 8 minutes left, so if there are any questions, I'd like to actually open up the floor for questions, and I'll leave this slide up so you can try to figure out what other sessions you might want to go to. Thank you. And there are 2 microphones. If you'd like to step up to microphones, I can answer any question. Can we turn the microphone on, please? There we go.
Okay. I have 2 questions. One is that is the other connection type like Wi-Fi Direct and Bluetooth also included in the communication APIs?
The question is, I heard Bluetooth and also like Wi-Fi Direct?
Wi-Fi Direct, yeah. Wi-Fi Direct.
Wi-Fi Direct. And the answer is nuanced. And the nuanced part of it is that regular Wi-Fi is certainly supported. Bluetooth and Wi-Fi Direct can be used by the proximity APIs. So if you do a tap and connect, those can make a Bluetooth connection, which is then just a proximity socket. It works just like the regular sockets, but has some more features in it. And that will happily work with Bluetooth, and that will happily work with Wi-Fi Direct, but only if you created it with the tap and connect. You can't create one any other way and have it work in them.
Okay.
But if you come up to me, by the way, I'll be at over in the App Expo later on in the platform area. And if you can actually tell me why you need those, I'd actually love to find out what you're doing with sockets that you want to do Bluetooth and Wi-Fi Direct.
Okay, sure. And my second question is that you mentioned that the capability setting can allow the Metro style application to punch through the firewall. And I'm wondering that if that third-party firewalls like Norton or McAfee they provided can still be punched through the capabilities?
And the answer is that if it's a certified firewall for Windows 8, yes, it can, because it's part of the certification requirements that you work with our system.
Okay. Thank you.
You'd have to talk to the firewall people who are actually hanging out over at the app area, over in the server, in the hardware area. Actually, way in the back at the server area. There's a fellow there who does all the firewall stuff, and he can actually tell you the answer to that. Right? Oh, and the question was that through Universal Plug and Play? And I don't know the answer, but over in the Application Expo area, there's people who know. Yes? Oh, there's a person over here first?
He was first.
Oh, okay.
I got two questions for you. The first one is, if you're creating like a Metro-style app, how do you, that's reliant on some sort of back-end service, how do you manage getting through a hotspot with it?
Wait, how do you manage getting through a hotspot?
Yeah, getting through a hotspot. You know, like basically, you know, I've got to basically deal with the terms and conditions page, right?
Ah, yes. Okay. The PM for that is at the 581 talk, and he can tell you exactly how we do it. I can make some speculations about our APIs, and I might point you at like our WebAuth API, but I don't know if that would actually solve your problem.
Okay. So, second question. I got it. So 581, right? Go talk to the 581 guy, right, for the hotspot. Second question is, what do you guys do to handle like VPN kind of situations, and do you still get the same set of data regarding the connection?
I don't know the answer to that. VPNs are supposed to show up as a regular network.
Right.
But I have not personally seen it work because I do not use VPNs.
Okay, well.
And the question is, do we get like cost information for a VPN? I don't know if we get the cost information for a VPN. Yes. Oh, there you go. We have an answer from a person who should know. Yes, apparently we do get the cost information for VPNs.
Thank you.
Yes.
Does the WebSocket API set that you talk about support, or is related to the technique called HTTP parking that lets the client get eventual callbacks, sort of make a request that the server hangs onto for a while to get push notifications from the server?
And you called that HTTP parking?
That's what I've heard it called, I think.
I've heard that under the name of like long polling, and there's a Comet style and that sort of thing. It's related to them in that it's, among other things, trying to solve the same problems, in particular for web pages. But it's actually, in a lot of ways, a more elegant solution, and certainly more modern solution, a more recent solution. The primary advantage of a WebSocket over like parking is you get fewer connections to your server. And at the 581 talk, they'll be talking about that. As well as that, there's the 373 talk that talks about that, and a bunch of others. So we can get more information about WebSockets.
Thanks.
Any more questions? Yep, I see one in the back.
So earlier in the talk, you had mentioned the HTTP web client and the web request classes being new for .NET 4.5.
Yes.
So what about that is new? Because I could have sworn there were things as far back as 1.1 for...
Yeah. Sorry, apparently I was not fully clear. There's two different HTTP APIs that are available to you in a Metro-style app from .NET. And one of them is our new HTTP client API, as opposed to web client. So it's HTTP client now. And it's got a bunch of pipelining stuff and lets you compose a pipeline together that lets you handle a lot of auth and compression, for example, without cluttering up your business logic. And that's a brand new API. We also support the HTTP web request, and as you point out, yes, that API has been around for a while, and we're keeping that one because a lot of people use it and like it. But the other one you mentioned is actually not part of a Metro style, and you have to switch over to the HTTP client. It would be our recommendation.
I'd like to make my app network aware. Now, using the preview, what should I expect from the carriers out there at the moment? So, for example, AT&T with his 2 gig plan. I assume you are aware that it is a broadband connection, but what about when I'm near the limit or the 2 gig limit or over the 2 gig limit? Should that be exposed, and over what timeline do you expect carriers to start doing that, or the APIs to respond appropriately?
Boy, I wish... Actually, Diraj, are you still here? Yeah, can you answer that one, Diraj? Okay. This is Diraj, a PM from the team that does that.
Okay.
And if you can go up to the microphone.
Okay. So I lost some of the portion. Can you repeat the question again, please?
The question is, so for the slates they have or for the developer release, what's our actuals, how many broadband providers, mobile broadband providers, actually support this new cost information?
So currently, in the preview release, the AT&T, which is integrated right now, is providing the cost information and is integrated in Windows Preview Developer Platform. As we go along, this thing, we work with various other operators.
Does AT&T say when you're near the cap, the 2 gig limit, or is it just say it is capped?
It will send you a notification when you are 80%,
Okay.
and as well as when you reach to the cap. Okay.
All right, and I see we're 16 seconds left. So I'm going to have to say thank you all. Actually, we're over. I'm sorry. We're 22 seconds over. So I'm going to be over in the app booth area if you have any more questions or you have questions that you want team members to ask. Thank you.